I'm Abigaille, and this is our story of the sun. Today we'll be talking about Solarwind, Sunspots, Cmes, and helioseismology. Here are my fellow colleagues, Jazhira, Camryn, and Konnor. Up next is Konnor.
Our core concept is how matter relates to the sun. For example, how the sun is made of plasma and gas. Knowing what type of matter something is can help us also know its characteristics, which also means that we know what tools to study. Next, Camryn will come on to explain sunspots.
This is a sunspot. A sunspot is a large giant area that forms the sun's photosphere. They appear dark because they're cooler than surrounding areas. They can be as much as 100 miles to 100,000 miles big.
Our next phenomena is Cmes. A CME is a gigantic outward explosion from the sun. These abnormalities are caused by the sun's solar magnetic field. These powerful ejections can reach up to 1 million miles per hour. When the plasma hits Earth, it causes a geomagnetic storm. These storms press in the day-side magnetic field and elongates the night side. Eventually, the magnetic field will rush back with incredible force. This could eventually cause aurora borealis happening farther away from the poles. The most dangerous thing could be the CME's effect on technology. The massive amounts of magnetic activity and electrical currents could severely damage many different electronic devices. Next, we have Abigaille talking about solar winds.
The next phenomena is solar wind. Solar wind is a cloud of plasma that blows away from the sun. Solar wind is created when the sun's very high heat heats up the electrons, protons, and nuclei, which causes the particles to collect enough energy to break out of the sun in all directions. Solar wind can travel up to 300-400 kilometers per second. When the solar wind flows towards the Earth's magnetic field makes up a shield, protecting us from the solar wind. Some of the particles are pushed towards the Earth's polar regions, which causes the aurora borealis, also known as the northern lights. Up next is Konnor with helioseismology.
One career that interested us is being a helioseismologist. A helioseismologist is a bit like a seismologist. They both study the insides of something by watching sound waves. Studying these sound waves helps scientists understand the inside structure of celestial bodies like the sun and how it works. Helioseismologists branch off of solar physicists. To become a solar physicist, you must have a physics and math background. Helioseismology helps us understand our sun better because we need to know about our sun so we can be prepared for things like solar storms, CMEs, and solar flares. Also, surprise, secret thing, you didn't expect this, hee hee, star life.
Here's a quick run-through of a star's life. A star starts as a nebula, a big cloud of dust and gas. The nebula's gravity then pulls it in to create a protostar. Once a protostar gets hot enough, it will start nuclear fusion. Nuclear fusion is when the protostar turns hydrogen to helium. That is called the main sequence stage. It will stay in this stage for up to 4 to 5 billion years. When it runs out of its nuclear fuel, it will become a red giant and expand greatly. Once that stops, it will then become a planetary nebula. It will cool down more and more and more until it becomes a white dwarf. And once it cools down to its final stage, it will become a black dwarf.
Thank you for watching. We hope you learned something about our sun in this video.